Many people suffer from the results of intense wear and tear on their knee joints. For a great many of these patients, a knee joint prosthesis is often the only option for restoring normal mobility, which brings with it a considerable improvement in one's quality of life. The prostheses fulfill the crucial function of the joints, but exhibit a high degree of wear, particularly in the case of hips and knees, depending on how much load and movement they're subjected to. Abrasion particles are often released due to rubbing between the polyethylene friction-bearing and metallic components of the implant. When subjected to corrosive friction, metallic components of the prosthesis itself can also release metal ions into the surrounding tissue. The resultant wear and abrasion particles have been shown to be the main causes for inflammation and can lead to premature loosening of prostheses. Although prostheses made of titanium or cobalt-based alloys have taken hold on the market, they do have certain limitations. Thus, implants made of titanium alloys, for example, cannot be used in areas subjected to high tribological stresses because they exhibit a relatively low resistance to wear. A complete ceramic coating of the implant components with a layer of titanium nitride can increase resistance to wear and considerably expand the range of uses for the implants. Using the arc PVD technique, titanium nitride layers are applied to titanium and cobalt chromium alloys. This technique is distinguished by a very high ion density, excellent efficiency, and outstanding process security. In the PVD coating equipment, the implants are fixed on a turntable inside of the vacuum chamber. The coating sources, or targets, are installed in the walls of the unit. For titanium nitride coating, the target is made of a titanium alloy. The first step is to create a vacuum in the chamber. Next, the titanium atoms are liberated from the target by supplying electrical energy, are ionized, and then accelerated in the direction of the implant surface. During this process, nitrogen is added to the vacuum chamber, and the nitrogen atoms bond to titanium ions neutralized at the implant surface to form the desired titanium nitride layer. A meticulous computer-controlled production technique ensures high reproducibility and process reliability. PVD coatings only modify the surface properties. The material properties and biomechanical functionality of the implant are not altered by the coating. The titanium nitride coating has a thickness of approximately 5 microns. The roughness of the titanium nitride layer is in the range less than or equal to 0.05 microns. The hardness of the titanium nitride layer is approximately 2,400 HV, well above the results measured for conventional cobalt chromium molybdenum alloys. The most important parameter of the titanium nitride layer is the adhesive strength, which has been verified in various qualitative tests. These include the Rockwell impression test and mandrel bending test. Both testing methods showed that the titanium nitride layer exhibited very good adhesive strength. As evidence of the resistance to wear, titanium nitride-coated knee joint prostheses were examined in a simulation in which the components were subjected to 1 × 10⁷ load cycles. Next, the surface of the contact zone was analyzed. During the entire trial, no extensive change to the coated surface was found. No chipping or rubbing off of the layer occurred. In a wear test according to ISO standard 14243, titanium nitride-coated knee implants showed a PE wear reduction of 38% compared to uncoated cobalt chrome components. In order to examine how the titanium nitride layer affects the strength of the material, a dynamic rotating bending test, as described in ASTM F1160, was performed with a maximum cycle of n = 10⁷. The result of this test showed a 5% increase in the fatigue strength of titanium nitride-coated samples compared to an uncoated base material made of cobalt chromium. Titanium nitride coatings for implant alloys have been available for more than 14 years for the purposes of wear protection. Since 2003, more than 190,000 implants have been coated with titanium nitride. The clinical results of the coating speak for themselves. DOT offers you innovative surface finishes for medical implants. In close cooperation, DOT and ImplantCast improve your quality of life. Just talk to us.